Which one of the following is a difference of squares? Remember, by definition, difference of squares means a square minus b square. So you have the first term is a perfect square and the second term is a perfect square. And by perfect square, it means a number that you multiply by itself and gives you an answer. So the answer part is a perfect square. So for example, here, I'm going to write my parentheses here kind of just so I can organize my work. Can you think of a number that if you multiply that number by itself, you're going to get 32? So there's no number that we can multiply by itself that we can get 32. We could get 1 times 1 and get 1 here. So 1 is a perfect square. So because we don't have a number that we can multiply by itself and get 32, this one's not a difference of squares. So let's look at B. Again, let's see if we can find a number or combination of numbers and letters that if we multiply them by themselves, we're going to get 4x squared y squared. So 2 times 2 gives us a 4. X times x gives us x squared. Y times y gives us y squared. And then for this term, we can go 5 times 5 gives us 25, and z times z gives us z squared. So this one works. If we look at this one here, we have x times x that gives us this x squared, and 6 times 6, this gives us 36. However, we don't have a difference here. Remember, difference in math means subtraction. So we don't have a subtraction sign here. So this problem, although the first term and the second term are perfect squares, we don't have that minus sign, so it's not a difference of squares. We look at the last one, D. And we can write 5 times 5 to get 25, but we can't find a variable that if we multiply it by itself will give us y cubed. If we put a y times y will give us y squared, but we need y cubed. So we can't find a variable here that if we multiply it can give us this one here. So this is not a perfect square, so therefore D will not work either. So which one of the following is a difference of squares? The answer is B. B is the only one that has two perfect square. The first term is a perfect square, the second term is a perfect square, and we have a subtraction sign in between.